Michael Faraday was one of the greats of physics, standing like a guidepost between Newton and Einstein. Unlike most of his contemporaries, he was primarily interested in the why of his experiments. In 1822, he made a diary entry for himself: convert magnetism into electricity. 9 years later, he did just that, with the principle demonstrated here. Late 18th century experimental scientists were beginning to believe everything was electrical, a truth that would be borne out 200 years later. Public lecture shows were the reality TV entertainment of the day. Though the demonstrations were sensational, few believed anything practical would ever come of these delightful phenomena. However, the unification of magnetism and electricity would soon change this attitude. It was a unification that began in 1821, when William Sturgeon built the first electromagnet by wrapping an iron core with copper wire and attaching the leads to a battery. This electromagnet had all the properties of natural lodestones. Sturgeon also made the first electric motor. Using the principle that magnets push and pull each other, he constructed an apparatus that looked something like this. When the switch was thrown, the copper wire became an electromagnet that spun around by the push and pull of the permanent magnets. This simple motor is virtually identical to the ones found everywhere in the home today. Fans, vacuum cleaners, washers, and dryers. And the list goes on. Like the home user of motors, Sturgeon was not concerned with how his inventions worked as long as they did what they were supposed to do. But Michael Faraday was a different kind of scientist and inventor. He wanted to know how these forces worked and why they did what they did. In 1831, Faraday fulfilled his own directive of 9 years earlier when he discovered electromagnetic induction. With an experimental setup like this one, he produced electricity from magnetism. When the magnet passed through the copper coil, for a brief moment the needle tipped in one direction and then went back to zero. Moving back in the other direction once again produced the tip of the needle also in the opposite direction. Electricity was being produced. How could this be? And why was there only electricity for a brief moment? With startling intuitive reasoning, Faraday hypothesized that the movement of a conductor through a magnetic field was the important factor. Send a coiled wire back and forth through a horseshoe magnet, and the bulb lights up like the one shown here. Faraday was right. It's the movement through the magnetic field that produced his experimental results. In another of Faraday's experiments, the expansion and contraction of the magnetic field produced electricity in an adjacent wire. Amazingly, in that very simple setup, Faraday had in fact built the first electrical transformer. Transformers that were not significantly different from the ones that dot the landscape in every developed country today. A year later, Faraday produced an even more spectacular application of electromagnetic principles, Faraday's Dynamo or electric generator. By taking a permanent horseshoe magnet and cranking a copper disc through the magnetic field, Faraday was able to generate a steady electrical current. Again, this setup was not significantly different from what is found in a modern power plant. Faraday then went on to state, the faster the turning, the bigger the magnet, the more coiling of the wire, the more electricity that can be produced. A modern power plant does just that. It converts mechanical movement powered by heated water to spin an enormous coil of wire inside a giant magnet. In electrical generation of power, bigger is indeed better. Faraday's discoveries and laws set the stage for the era of electrical inventions 50 years later, and the insatiable consumption of electricity by the industrial and post-industrial ages. Equally as important, Faraday laid the foundation for the unification of electricity and magnetism, a unification that would be simplified by the Scottish physicist James Clerk Maxwell.